In this presentation, we will learn octal to binary and binary to octal conversion. There are 8 different digits in octal number system. If you remember the first presentation on number systems, I told you base in case of octal number system is equal to 8. So R is equal to 8 in octal number system, and hence we have 0 to 8 minus 1 different digits in octal number system. It means 0 to 7. I have already written the digits in octal number system 0 to 7, and each one of these can be represented by equivalent 3-bit number. The most important part of this presentation, that we can represent each one of these by equivalent 3-bit number. 0 I can represent by 0 0 0 3-bit number. 1 I can represent as 0 0 1. In the same way, 2 will be represented as 0 1 0. 3 we can write 0 1 1. 1 0 0 for 4. 101 is for 5, 110 is for 6, and 111 is for 7. So this is how we can represent the 8 octal numbers by equivalent 3-bit number. This will be more clear when we solve one example. First we will see octal to binary conversion. The octal number is 37.45. This is in octal, and we want the binary equivalent of this number. From this table, we can write 3 as 0, 1, 1. 3 we can write 0, 1, 1. 7 we can write 1, 1, 1. So 1, 1, 1. Now we have point here. 4 we can write 1, 0, 0. 1, 0, 0. 5 we can write 1, 0, 1. So binary equivalent of this octal number is 0, 1, 1, 1, 1, 1, point 1, 0, 0, 1, 0, 0, 1, 0, 1. 101. This is the binary equivalent of this octal number. It is very easy to convert octal number to binary. We will see one more example on this. The second example, the octal number is 22.07. This is in octal, and we want binary equivalent of this octal number. 2 we can write 010. So 010. Again we have 2. So I will write 010. Then we have point. 0 is written as 000, and 7 we can write 111. So this is the binary equivalent for 22.07. Now we will move to binary to octal conversion. The next part of this presentation is binary to octal conversion. Let's move to first example. The binary number is 10110.11. This is the binary number, and we want octal equivalent of this binary number. We will again use this table. Binary to octal conversion is little bit tricky as compared to octal to binary. In this case, we have to make group of 3 bits, and first we have to locate the binary point. This is the binary point, and for integer part we have to move from right to left, and for fractional part we have to move from left to right. In first group we have 110. In second group we have 010. I can add 0 here to make this 3-bit. Adding 0 here will make no difference in the number. So this is the first group. This is the second group. We have group of 3 bits. And now we will move to fractional part. We have to start from left and we have to move to right. So the first group for the fractional part will have 110. Adding 0 here will make no change in the number. Now I will use this table. 010 is 2. 010 is 2. So we have 2. 110. 110 is 6. So we have 6. Then I have point. And 110 is again equal to 6. So we have 6. So the octal equivalent of this binary number is 26.6. Now we will move to second example. The second example, the binary number is 1001.1. This is in binary, and we want octal equivalent of this number. For integer part, we will start from right to left. In first group, we have 001. In second group, I will add 2 zeros, and we have 001 again. For the fractional part, I will add 2 zeros. This will give me 100. 001 is 1 and 100 is 4. So 11.4 is the octal equivalent of this number. I am adding zeros to have the group of 3 bits. You can also add 3 more zeros, and this will be the third group of the integer part. 000 will give us 0. This 0 will make no difference, so it is redundant to add this 0. This is all for binary to octal conversion. Now we will move to homework problem. In first problem, the octal number is 672.13. This is in octal, and you have to find the binary equivalent of this octal number. In the second problem, we have binary number 10111 011 0.1001. This is the binary number, and you have to find the octal equivalent of this binary number. So this is all for this presentation. See you in the next one.